What holds a galaxy together when the stars within it should be flying apart? It was in the cold silence of the 1930s that this unsettling question first emerged. Astronomer Fritz Zwicky gazed at the Coma Cluster, a gathering of thousands of galaxies adrift in the darkness. By the rules of visible matter alone, their furious motion should have torn the cluster apart. Yet they clung together, bound by something unseen. Zwicky gave it a name: Dunkel, Materie, dark matter. His claim was audacious, whispered almost as an accusation against the universe itself. Most dismissed it as an error, a miscalculation buried in the noise of primitive instruments. But the seed of doubt had been planted. 4 decades later, the night skies offered their next revelation. Vera Rubin, measuring the rotation curves of spiral galaxies, traced the elegant whirl of stars around their centers. What she found defied expectation. The outer stars moved not slower, as gravity's laws demanded, but with the same unrelenting speed as those near the core. It was as if galaxies were embedded in vast, invisible halos, ghostly scaffolds holding them together. Rubin's quiet persistence transformed the whispers of Zwicky into a scientific storm. Skepticism lingered. Could the starlight have been misread? Could hidden gas or cosmic dust account for the missing mass? Yet every refinement, every new telescope only deepened the riddle. The invisible outweighed the visible. The cosmos was not as it appeared. Thus began one of the greatest mysteries in science, a universe where the familiar stars, planets, gas, dust was only a faint surface, and beneath it stretched a dark foundation that no eye could see. Matter had stepped from speculation into reality, and with it, the haunting question remained. If most of the universe is hidden, how little do we truly know of the world we live in? The universe has always spoken in light. Every discovery humanity made about the cosmos, every chart of the stars, every photograph of galaxies, every delicate spectrum etched into glass was born from the language of photons. The glow of stars, the faint whisper of nebulae, the fiery pulse of quasars, all of it carried across the void by light pouring into our telescopes, telling us what was there. For centuries, it was enough to believe that what we could see was what the universe truly was. But the shock waiting in the depths of the 20th century revealed that light had deceived us. The cosmos is not what it seems. Cosmos is mostly invisible. The realization unfolded slowly, like a curtain being drawn back on a stage. We thought we understood. First came the whispers: Zwicky's galaxies moving too fast, Rubin's spirals refusing to obey Newton's law. Then came the proof that would shake physics to its foundations: the visible universe. All the stars, planets, gas, and dust made up less than 5% of everything that exists. The rest, the overwhelming majority, was something else, something unseen, something that did not shine, did not absorb, did not reveal itself through any familiar means. Astronomers gave it a name that carried both awe and unease: dark matter. Its presence was inferred only through its pull. Like an invisible hand, it tightened its grip around galaxies, refusing to let them fly apart. It sculpted the clusters of galaxies, knitting them into immense tapestries. It threaded the cosmos with filaments that stretched for hundreds of millions of light years, forming the vast web upon which every star and galaxy is hung. The dark was not absence, it was structure. The shock was not only scientific, it was existential. Humanity had imagined itself perched on a clear stage, gazing out into a universe of shining stars. But suddenly the lights dimmed, and it became clear the stage was built on shadows. The luminous world, the one that filled our eyes and our imaginations, was only a thin glaze on the surface of something far vaster, far stranger. What does it mean to live in a universe where the familiar is only a fraction of the truth? The paradox was almost unbearable. The equations of Newton carried us to the moon. Einstein's relativity had explained the bending of starlight and the clockwork of black holes. Yet none of these great pillars of understanding had prepared us for matter that refused to reveal itself. In every textbook, matter was defined by its interaction: atoms with electrons orbiting, photons scattering, particles colliding, but dark matter followed none of these rules. It neither emitted light nor absorbed it, did not leave trails. In particle detectors, did not flash across a sensor, did not flicker on a photographic plate, and yet its gravity was undeniable. Galaxies could not exist without it. Clusters of galaxies would dissolve without its anchor. Even the delicate ripples of the cosmic microwave background, the afterglow of the Big Bang, itself showed patterns that betrayed the presence of unseen mass. The universe was a canvas painted with invisible strokes. For scientists, the confrontation was both exhilarating and terrifying. Exhilarating because it revealed a frontier larger than any before. Terrifying because it meant that humanity's grasp of reality was paper-thin. To think that the universe was mostly made of something utterly unknown was to confront the limits of knowledge itself. The deeper they looked, the more extreme the picture became. Computer simulations of the early universe showed that, without dark matter, galaxies could never have formed. Ordinary matter alone was too weak, too slow to clump together in time. It was the dark component that seeded the great architecture of the cosmos, guiding the rivers of gas, pulling stars into spirals, gathering dust into worlds. In a sense, dark matter was the true author of the universe we inhabit, yet no telescope, no detector. No experiment could glimpse it directly. It is difficult to overstate the shock. Imagine building your entire understanding of the world on the surface of an ocean, only to realize that beneath the waves lies a depth hundreds of times greater than what you had ever conceived. Such was the revelation of dark matter. The cosmos was not an ocean of light. It was an ocean of shadows, and we were only beginning to wade into it. For philosophers, poets, and physicists alike, the implications cut deep. What is reality if the vast majority of it is hidden? What does it mean to exist in a universe where the known is dwarfed by the unknown? The stars above, once seen as eternal guides, became fragile embers clinging to scaffolds of something unseeable. Humanity, which had once believed itself to be uncovering the full story of the cosmos, now understood it had only read the prologue. Some resisted the idea at first. Perhaps the laws of gravity themselves were wrong. Perhaps Newton and Einstein had failed at the largest scales. The thought was both radical and strangely comforting. If gravity behaved differently in the vast expanses of space, then maybe there was no invisible matter at all. Maybe the universe was simpler, its strangeness only a flaw in our understanding of force. But as evidence mounted from the bullet cluster where dark matter separated visibly from normal matter during a galactic collision, to the precise measurements of the Planck satellite, those hopes fell away. Gravity was not broken. Something else was there. Dark matter was not a shadow born of error. It was a shadow born of truth. And so the shock settled into a kind of haunting permanence. Every map of the universe became incomplete, every simulation partial. Astronomers now spoke of halos and filaments and webs, knowing that they described not only what was seen, but what could not be seen. The very language of science bent around the invisible, yet the mystery remains unresolved. Decades have passed. Since Wiki's bold claim, since Rubin's careful rotations, and still dark matter has not revealed its face. It is a ghost that leaves footprints, but never a shadow. A presence felt in every corner of the cosmos. And yet a riddle that defies capture. The shock of its discovery has not faded, has only deepened. For it was not just the unveiling of a new piece of knowledge. It was a revelation that knowledge itself is fragile, that light can only carry us so far, that the universe hides more than it reveals, and so humanity stands at a threshold, gazing out into a reality that is 95% unseen. The visible world, the galaxies glowing in the night, the stars that guided ships and inspired myths, not the true stage of existence. It is only the ornament, draped across a framework of darkness. The question remains suspended in the silence of the cosmos. What is this invisible matter that rules the universe? And why has it hidden from us so well? For in every star's orbit, in every cluster's grip, in every map of the cosmic web, the answer lingers, unspeaking, unresolved. The shock of dark matter is not merely that it exists, but that it refuses to be known. It is a reminder that the universe is not obliged to reveal its secrets, no matter how much light we chase. The universe keeps its oldest memory in light, not in the light of stars or galaxies, for those are late arrivals, but in the faint glow left over from the beginning itself, the cosmic microwave background. It is the whisper of the Big Bang, stretched thin across time, a veil of radiation, now colder than the frost of deep space. It's still carrying within it the story of creation. In the 1990s, the COBE satellite first traced that whisper with exquisite care. Later, WMAP sharpened its patterns, and then Planck revealed them with almost painful precision. What appeared was not a smooth glow, but a canvas mottled with tiny ripples, subtle variations in temperature only 1 part in 100,000. These ripples were not noise, they were fingerprints. They marked the places where matter clumped together in the infant universe, seeds from which galaxies and clusters would eventually form. Yet when scientists read these patterns, a strange imbalance emerged. The visible matter, the ordinary atoms forged in the Big Bang, was not enough to account for the structures written into the microwave background. To make the universe we see today, to build galaxies, clusters, and the great filaments that span billions of light years, something more had to exist. A deeper foundation, heavier than all the stars combined. Shaping the universe long before its first light could shine, dark matter had left its imprint on the oldest canvas of time. Even before galaxies, it was there, shepherding the growth of structure, sculpting the universe we now inhabit. The evidence was no longer confined to the motions of galaxies. It was etched into the very radiation that surrounds us, the afterglow of creation itself, but the cosmos offered more than light as testimony. It offered collisions in 2006. Astronomers studying the bullet cluster saw an event that would become one of the most striking proofs of dark matter's existence. 2 massive clusters of galaxies had collided, a cataclysm played out over hundreds of millions of years. The visible matter clouds of hot gas slammed together, heated by the violence, and shone in XRS. But gravitational lensing revealed a different story. The greatest concentrations of mass were not where the gas lingered. They had passed through one another, barely slowed. The invisible mass dark matter had separated itself cleanly from the visible, as though 2 worlds had brushed past each other, distinct and untouching. The bullet cluster became a cosmic experiment, nature's own laboratory. No modification of gravity alone could explain it. The lensing showed mass that was not luminous, mass that moved independently from the gas and stars. Here, in the silent depths of intergalactic space, the shadow world revealed itself not in form, not in face, but in action. And still, the picture grew deeper. With the rise of supercomputers, scientists began to simulate the universe itself. Starting from the conditions revealed in the cosmic microwave background, they let gravity weave its patient web. What emerged on their screens was astonishing. Vast filaments stretched across space, forming a cosmic lattice. Galaxies clustered along these threads like beads on invisible strings. At the intersections, immense knots of matter gathered, birthing clusters of galaxies. And at every scale, from the smallest halo to the grandest cosmic wall, the pattern was the same, dark. Matter was the skeleton. Without it, the universe unraveled. Simulations without dark matter produced chaos. Galaxies that failed to form, structures that dissolved before they could stabilize, a universe that bore no resemblance to the one above us. With it, the universe looked eerily familiar. That the match between simulated structures and real galaxy surveys left little doubt. The unseen mass was not a hypothesis of convenience. It was a necessity. And yet the paradox deepened. Every new discovery, every fresh line of evidence confirmed that dark matter was real, but its nature remained hidden. The cosmic microwave background proved its weight. The bullet cluster revealed its independence. Simulations showed its hand, guiding the largest structures, but not a single photon had been caught, not a single particle detected. the facelessness of dark matter became almost a character in itself, a cosmic presence that resisted exposure. It left its footprints in the oldest light, in the lensing of galaxies, in the shape of the universe itself. But when asked to show itself, it remained silent. For scientists, this silence is both a triumph and a torment. Triumph, because never before had humanity uncovered a phenomenon so universal, so fundamental, through such delicate inference. A torment, because inference is not identity. To know that something exists is not the same as knowing what it is. And in that gulf lies the central riddle of modern cosmology. The deeper they looked, the more the universe seemed like a double world, one visible, blazing with stars and galaxies, a universe of light; the other invisible, woven of shadows, a universe of scaffolds and skeletons, binding and shaping all we see. Between them, a thin boundary of ignorance. What if this ignorance is not temporary? What if dark matter is of a kind beyond human grasp, a form of matter that never shares its face with light, never collides with our instruments, never bends to the methods we use to measure reality? Every discovery so far has only heightened this possibility. Cosmic microwave background proves it shapes the earliest structures. The bullet cluster proves it moves independently of normal matter. Simulations prove it sculpts the universe itself. But none of these reveal its essence. The faceless universe is real, but still faceless. And so, the investigation continues, deepened by both evidence and absence. For in science, as in philosophy, sometimes the greatest mysteries are not those we cannot see, but those that show themselves in every way except directly. Dark matter has become such a mystery, everywhere present, nowhere revealed, and in its silence it forces a reflection that goes beyond astronomy. Perhaps the universe is not meant to be fully illuminated. Perhaps its greatest truths dwell in shadow, shaping the light we see without ever entering it. The deeper science searched for dark matter, the more elusive it became. It was everywhere in the heavens, shaping galaxies, sculpting clusters, written into the very architecture of the cosmos. Yet when the instruments of physics were turned upon it, it vanished into silence. For decades, scientists built traps in the deepest places on Earth, hoping to catch even the faintest whisper of interaction. Deep beneath mountains in Italy, within abandoned mines in South Dakota, in caverns carved under the Alps, vast tanks of liquid xenon and argon waited in darkness. They were shielded from cosmic rays, isolated from natural radioactivity, held in silence, colder than space itself. Here, in the most pristine environments imaginable, scientists waited for the ghostly collision of a dark matter particle with an ordinary atom. The candidates had names: WIMPs, axions, sterile neutrinos. WIMPs, or weakly interacting massive particles, were once the leading hope, born of theories that extended the standard model of particle physics. They seemed to fit perfectly, heavy enough to hold galaxies, weak enough to hide from detection, yet just interactive enough that once in a while they might brush against normal matter. A single flicker of light in the detectors, a single electron disturbed, could be enough to prove their existence, but years turned to decades. Detectors grew more sensitive, their volumes expanded, their shielding perfected. Each new experiment promised that if WIMPs were there, they would finally appear. Yet again and again, the silence persisted. No collisions came. No faint signals pierced the darkness. The axion, too, became a candidate. A particle so light it would be almost ghostly, born from attempts to solve another mystery in quantum physics. Instruments were built to detect its subtle influence on electromagnetic fields, using resonant cavities and ultra-precise magnets. But here as well, silence ruled. Others turned to neutrinos, those nearly massless particles already known to slip through Earth by the trillions every second. Could there be another kind, sterile neutrinos that carried the hidden weight of the cosmos? Observatories searched, but results came back inconclusive, hints evaporating under scrutiny. The paradox deepened. In the sky, dark matter was undeniable. In the laboratory, it was untouchable. Each failure did more than frustrate. It sharpened the riddle. Perhaps dark matter was not a particle at all. Perhaps it was not matter in any familiar sense. Some whispered of primordial black holes, ancient relics formed in the first moments after the Big Bang, compact enough to lurk unseen, numerous enough to bind the universe. Others argued that the problem lay not with matter, but with the law of gravity itself. Modified Newtonian dynamics, or MOND, suggested that the equations of attraction were incomplete, that at vast scales, gravity behaved differently than Einstein and Newton had imagined. In this view, there was no hidden matter, only a hidden law. Yet MOND could not explain every observation. The bullet cluster stood as a stark contradiction. Galaxies colliding, dark matter separating from luminous gas in a way no alteration of gravity alone could predict. The cosmos seemed to insist dark matter was real. But still no face emerged. The haunting possibility grew stronger with every silent detector, every experiment that returned only emptiness. What if dark matter would never reveal itself? What if its very essence lay forever beyond the reach of our instruments, its nature hidden not by chance but by principle? Such a thought is more than scientific despair, it is a philosophical tremor. Humanity has always assumed that with patience, with better tools, the universe would yield its secrets, that the hidden could eventually be brought into the light. But dark matter challenges this faith. It may be a reminder that reality does not bend to human expectation, that there may be truths written into the cosmos that we are destined only to infer, never to grasp. Still, the search continues. Ever deeper, ever quieter, ever more refined, detectors lie in wait for the touch of the unseen. Instruments buried beneath kilometers of rock, cooled to temperatures near absolute zero, shielded from the faintest noise, listening for the faintest signal. Each one a temple of patience, built upon the hope that the silence might someday break. Yet, the silence itself has become a kind of voice, a reminder that the universe is stranger than imagination, and that knowledge itself may be bounded not by ignorance, but by the nature of existence. And so, the mystery deepens. Dark matter is no longer only a scientific puzzle. It has become a mirror, reflecting back the fragility of human understanding, the limits of light, the arrogance of assuming that all things must reveal themselves. It waits unseen, shaping galaxies, guiding stars, writing the story of the cosmos. And in its silence, it whispers the most haunting possibility of all, that some truths may be destined never to show their face. The deeper humanity peers into the dark, the more the universe begins to look like a riddle whispered in many voices. The evidence for dark matter is overwhelming, yet its identity remains hidden, like a silhouette behind an opaque veil. To pierce that veil, science has woven theories both elegant and audacious. Some speak of new particles, unseen cousins to the known building blocks of matter. Others suggest that perhaps the universe itself is tricking us, that gravity, the oldest and most trusted law, is not what we thought it was. And still others wander further, imagining dimensions curled beyond perception, or remnants of ancient black holes adrift since the dawn of time. Each idea carries with it hope, each is shadowed by doubt. The first suspects were the particles. Known as WIMPs, weakly interacting massive particles, they fit neatly into the framework of supersymmetry, a theoretical extension of physics that predicts heavier siblings for every known particle. WIMPs seemed to be nature's perfect answer, heavy enough to anchor galaxies, yet so shy in their interactions that they had evaded every detector thus far. Their very name captured their duality, massive enough to shape the cosmos, weak enough to remain unseen. For decades, WIMPs were the leading theory, the face many expected dark matter to finally wear. And yet the silence of underground detectors has begun to erode that confidence. No trace of their passage, no glimmer of their presence. The longer they remain hidden, the more the theory fries. In their absence, another candidate steps forward, the axion. Born not to explain the stars, but to solve a paradox deep within the quantum world. The axion is a particle of almost impossible lightness. Unlike WIMPs, it carries little mass, but it could exist in such vast numbers that together they form the dark skeleton of the universe. To detect them requires exquisite experiments, resonant cavities tuned to the faintest shifts in electromagnetic fields, like ears straining for whispers at the edge of silence. If axions exist, they may not only explain the cosmos, but also restore balance to the laws of quantum physics. Still, they remain phantoms, glimpsed only in equations. Another possibility lies with the neutrinos, ghostly particles already known to stream through the Earth by the trillions every second. Could there be another type, a sterile neutrino? Heavier and more elusive than the rest. So, their quiet presence might explain the unseen mass. Yet experiments searching for their signatures in cosmic radiation and galactic motions have found only hints that fade on closer inspection. Particles dominate the imagination of physicists because they offer continuity. They extend the familiar into the unknown. But as the years pass without a detection, some have begun to wonder. Perhaps there are no particles to find. Perhaps the problem is not hidden matter, but hidden laws. Here lies the idea of modified gravity. Modified Newtonian dynamics suggests that at the vast scales of galaxies, gravity behaves differently. Instead of weakening endlessly with distance, it holds more firmly, explaining why stars at the edges of galaxies do not drift away. Later refinements, such as TeVs, sought to blend Mond with Einstein's relativity, creating a new framework for cosmic attraction. Such theories offer a radical comfort. If correct, then the universe contains no mysterious shadow matter. There is only a new law waiting to be recognized. But comfort does not always survive confrontation. Observations like the bullet cluster, where dark matter separates cleanly from visible matter during collisions, defy modified gravity alone. Mont cannot explain the ripples in the cosmic microwave background, nor the full richness of cosmic structure. Gravity may yet hold surprises, but most evidence insists that unseen matter is real, still. Speculation presses outward, into wilder terrain. Some imagine that the dark is woven not from particles, but from primordial black holes, ancient relics, formed in the universe's first moments, like the massive black holes that lurk in galactic centers. These would be tiny, scattered in vast numbers, visible except through the gravitational microlensing they might cause as they drift between stars. If they exist, they would be fossils of creation itself, survivors from an era before light. Others look to supersymmetry in broader form. If nature truly doubles every particle, then a hidden mirror of the universe might exist, filled with heaviest partners whose gravity we feel, but whose light we never see. Supersymmetry promises to solve not only dark matter, but puzzles in particle physics itself. Yet despite the immense power of the Large Hadron Collider, no superpartners have emerged. The silence grows heavier, and beyond even this, some theories venture into the architecture of reality itself. Could dark matter be the shadow of hidden dimensions, curled tightly beyond our perception? Could particles move freely in spaces we cannot touch, their gravity leaking into ours? The mathematics of string theory whispers of such dimensions, of universes folded within universes. Perhaps the darkness we sense is not matter at all, but the echo of geometry we cannot inhabit. Each speculation carries a strange duality. It is at once bold and fragile. Bold, because it dares to reshape reality. Fragile, because the cosmos has so far withheld its confirmation. WIMPs, axions, sterile neutrinos, primordial black holes, supersymmetry, modified gravity, hidden dimensions each, rises in turn, only to falter before the silence of experiment. Yet this silence should not be mistaken for defeat. Science is not the act of finding answers quickly. It is the art of refining questions. Every failed search reshapes the boundaries of what might be true. Every quiet detector carves away a corner of possibility, narrowing the path toward discovery. The darkness becomes not emptier, but sharper. The puzzle remains suspended between two profound possibilities. Either the universe contains unseen matter particles or objects that await discovery, or the very laws of physics. The pillars on which centuries of knowledge rest must be rewritten. In one case, humanity will uncover a new form of matter, expanding the family of the cosmos. In the other, humanity will uncover a flaw in its most trusted understanding of nature. Both outcomes carry wonder. Both outcomes carry risk. For what does it mean to live in a universe where the majority of reality is missing from sight? What does it mean to imagine that the laws of nature themselves might not be final, that what Newton and Einstein built could yet be only fragments of a larger truth? Dark matter is not simply a problem for physics. It is a question of existence. It asks whether reality is stranger because of what it contains, or stranger because of how it works. It forces humanity to confront the humility of knowledge, the arrogance of thinking the cosmos must reveal itself in ways convenient to human instruments. And so the speculation continues. Each theory a candle lit in a cathedral of shadows. Some may flicker out, others may burn more brightly with time. One will one day illuminate the face of the unseen. Perhaps none will. Until then, the universe waits, its greatest secret woven into silence. The search for dark matter has become one of the most profound quests of modern science, a pursuit that bridges the smallest particles and the grandest structures of the cosmos. It is a search that reaches both deep into the earth and far into the heavens, deploying the most powerful machines humanity has ever built. And yet, despite this vast arsenal of tools, the face of dark matter remains hidden. A silence at the center of the most elaborate orchestra, on the borders of Switzerland. In France lies the Large Hadron Collider, a ring of superconducting magnets buried beneath the soil, 27 kilometers in circumference. It is a cathedral of acceleration, slamming protons together at near the speed of light, peeling back reality to glimpse particles unseen since the dawn of time. Within its detectors, physicists search for traces of supersymmetric partners, for heavy cousins that might reveal themselves in the wreckage of collisions. If WIMPs exist, the collider should, in theory, have uncovered hints of them by now. Yet the data flows in, year after year. And still no dark particle has stepped into the light. If the collider looks for creation in the violence of impact, other experiments search in the quietest stillness. Deep beneath mountains and mines, detectors like XENON1T in Italy and Lux Zeppelin in South Dakota wait in silence. Vast chambers of liquid xenon, shielded by rock from cosmic rays, chilled to temperatures colder than interstellar space, lie poised for the faintest flicker of interaction. A dark matter particle, should it pass through, might nudge an electron or create a trace of light in these perfect crystalline detectors. Each flash would be like a footprint of the unseen, a signature written in silence. But the tanks remain still. The years pass without a single confirmed signal. The sensitivity grows sharper, the detectors quieter, the hopes higher, and yet the silence holds. Still, the search widens. The Vera Rubin Observatory in Chile, set to open its eyes upon the heavens, will scan the night sky in unparalleled detail. By tracing the subtle distortions of galaxies caused by gravitational lensing, it will map the invisible scaffolding of dark matter across billions of light years. It will not see the particles directly, but it will trace their hand on the structure of the cosmos. Like shadows painted upon the canvas of time, the Euclid spacecraft, launched by the European Space Agency, now surveys the sky with the same purpose: to measure the geometry of the universe itself, to chart the invisible web. Each galaxy, each filament, becomes a data point in a grand cartography of darkness. Through lensing, through clustering, through the slow bending of light, dark matter reveals its architecture, not its essence. Even the James Webb Space Telescope, though built to peer at the first galaxies, contributes to this search. By pushing vision to the earliest epochs of star formation, it measures how galaxies grew in the shadow of unseen mass. Its golden mirrors, gazing into the deep past, see not only what is luminous, but what is missing. And still, the search does not end with light. Some suspect that if dark matter is not particle but remnant, if it is composed of primordial black, holes forged in the first seconds after the Big Bang, then it may whisper through gravitational waves. The observatories of LIGO and Virgo listen for ripples in space-time, the echoes of ancient mergers. Future detectors LISA in space, Einstein. Telescope on Earth may reveal subtler signals, hints of black holes too small and too ancient to explain by stellar collapse alone. If such relics exist, they may be fossils of the universe itself, hidden in the void for billions of years. Each machine, each experiment, is a question asked of the cosmos. The collider demands, will the particles reveal themselves in fire? Xenon tanks ask, will they brush against matter in silence? The observatories ask, will their gravity distort the light of galaxies? Will their mergers ripple the fabric of time? And yet the answers so far have been silence, silence, silence. This silence is not empty. It is data. It narrows the field, erases the impossible, reshapes the frontier of possibility. Every null result deepens the paradox, but it also sharpens the riddle, like a sculptor removing stone to find the form within. The absence of signals does not mean the absence of truth. It means the truth is stranger than expected. The suspense grows heavier with each year of searching. Humanity has built machines that dig into the heart of matter, that listen to the oldest light, that map the universe itself. And still, the greatest component of the cosmos hides beyond reach. Perhaps it interacts only through gravity, never through the forces we know. Perhaps it is not matter at all, but geometry, dimension, or something stranger still. The pursuit is relentless, because the stakes are not small. To glimpse dark matter is to glimpse a deeper layer of reality. 2. Extend the human story beyond the surface of the scene. To fail is to confront the possibility that not all mysteries yield to light, that some remain forever in shadow. For now, the detectors remain vigilant. The collider roars to life with each new run. The observatories sweep their gaze across the night. The satellites chart the cosmos from above. The silence holds, thick with promise, heavy with mystery. The universe has given its clues. Galaxies that spin too fast. Clusters that cling too tightly. Light that bends where no matter is seen. But the face of dark matter remains hidden. Humanity stands surrounded by instruments of astonishing power. Yet the cosmos refuses to speak. It is a suspense unlike any other in science, awaiting not for proof that something exists for that. Proof is everywhere but for the unveiling of its nature, for the moment when the faceless becomes known, and until that moment arrives, each experiment, each telescope, each detector is a question suspended in the silence of the universe. Will dark matter ever reveal itself? Or is its facelessness the truest revelation of all? Humanity drifts through a universe it does not fully know. Above, the stars burn with ancient fire, guiding myths and sciences alike. Yet these lights, dazzling as they are, belong to a fragile minority. They are but the bright foam upon an unseen ocean. Beneath them lies a greater, darker expanse, an invisible sea of mass and meaning, silent and enduring, within which the luminous world is only a decoration. Dark matter is more than a scientific puzzle. It is a metaphor of existence itself, the unseen shaping the seen, the hidden supporting the visible, the unknown giving form to the known. In this way, it reflects not only the universe, but the human condition. For life too is guided by forces that remain unspoken, by structures invisible yet binding, memory, time, gravity itself. Science has chased dark matter with instruments vast and delicate, with machines that thunder in collisions and chambers that wait in silence. Yet the search, no matter how technical, has always carried with it something deeper. The mystery forces humanity to confront its place in reality, to ask whether knowledge is destined to complete itself, or whether some truths are meant only to be sensed, never revealed. Perhaps dark matter will someday step from shadow into form. Perhaps a signal in a detector, a flash in xenon, a pattern in the heavens will finally name it. But perhaps its essence is not meant for the human eye. Perhaps its role is not to be seen, but to remain the silent stage upon which all else occurs. For galaxies would not hold together without it. Clusters would unravel. Stars would drift away into the void. Even the great filaments of the cosmic web would not exist. Dark matter, unseen, defines the very architecture of the universe. It does not merely accompany the galaxies it frames. Conducts them, sets the tempo of their dance, This truth carries a kind of poetry, that the universe in its vastness relies on the invisible, that existence is built upon what cannot be directly known, that reality is larger than perception, deeper than light. Humanity has always trusted its senses, trusted that the visible world is the real one. Dark matter whispers otherwise. It says that what is most essential may be hidden, that what endures is not always what shines. The philosophical weight is immense. If 95% of the cosmos is unseen, what then of the stories we tell about truth, certainty, and knowledge? If the luminous is only surface, can we claim to know reality at all? Or are we wanderers on a vast shore, tracing patterns in the foam while the depths remain uncharted? Yet there is no despair in this. The unknown is not emptiness, it is possibility. The darkness is not absence, it is foundation. Dark matter, faceless as it is, reveals something profound, that the universe does not need to show itself fully. In order to be real, that what is hidden may still be central, that mystery itself may be the truest condition of existence. Humanity has always longed to illuminate the shadows, to replace wonder with knowledge. But perhaps wonder is knowledge of another kind. Perhaps the role of mystery is not to frustrate, but to remind us of the humility of our place. To remind us that the cosmos is larger than any map we may draw of it, larger than any equation we may write. Even if dark matter never reveals its face, it will remain the silent architect of everything we see. Every spiral arm of every galaxy, every cluster clinging together, every filament stretched across billions of light years is written in its unseen hand. The stars that shine above do so because the darkness holds them in place. In this way, the universe itself becomes a reflection. Light without dark is fragile, fleeting. Knowledge without mystery is shallow, incomplete. The cosmos teaches that both are needed, the visible and the hidden, the flame and the shadow. And so humanity sails on, a species surrounded by an invisible ocean, navigating only by the faint lights of stars. Each discovery pushes back the horizon, yet each horizon reveals a greater darkness beyond. Perhaps one day the veil will lift, the face of dark matter will stand revealed. Or perhaps the veil itself is permanent, a feature of reality as true as time or gravity. The question is not only whether dark matter will reveal itself, but whether humanity is ready to face what such a revelation might mean. For the greatest truths of the cosmos are not written in light. They are hidden in shadow. The closing line is whispered by the silence of the universe itself. The cosmos hides its greatest truths in shadow. The question is not only whether dark matter will reveal its face, but whether we are ready to see it.